Hello, Math 111. This is Gary, your coach. So I'm going to do a little Math 111 review right now. Chapter 1, main theme, idea of a function. Now, you've played with functions a little bit in Math 95 and in Math 70. So I'm going to start off with the simplest kind of function there is, the idea of a linear function. So for example, I might have the function y equals 5x plus 2. Function has an independent variable and a dependent variable. Think back to making a table xy. Usually we pick numbers for x, like -1, 0, 1. We plug it in. 5 times -1 plus 2 gives us what? -5 plus 2, which is -3. So that right there is our output, the value of our dependent variable. So choosing an x, y is dependent upon that. If we plug in 0, 5 times 0 plus 2 gives us 2. Now remember, parentheses, very important. Especially with substitutions, you got to practice safe math and wrap it in parentheses. Words to live by. Plugging in 1, 5 times 1 is 5, plus 2 is 7. So these guys over here are our output. X's are our input. Okay? So a function is something where we have an input. The input leads to only one output for any input. So the number -1 leads to only the number -3 and no other number. That's important for being a function. If something does have that property where we plug a number in and out pops one and only one number, sometimes we get no number, that's okay, but we can't have more than one. Like it would be bad, function-wise, if I were to plug in a number like 4 and then out popped 2 or -2. Okay? Not a function. It happens in math. I can think of some reasons. Given 4, I might want to state 2 or -2. Sorry about the jingling. That's my dog, Bo. So again, function, big idea, input leads to only one output. This particular function I could then graph. Now, quick graph of this sucker. Given those values, -1 for x, 0 and 1, y could be -3 down here somewhere, 2 or 7 somewhere up there. Graph paper is much better. I highly recommend graph paper. So I have the point, what, -1, -3. That sucker lives about right there. I have the point 0, 2, about right there. And I have the point 1, 7. That's about right there. Now I mentioned this is a linear function, so the points should line up. And I don't see my ruler nearby, so grab anything straight, like an iPhone, and draw a line. Now if your points are supposed to line up and they don't, make them bigger. That usually helps. Okay, so that is a linear function. Other way you can tell something's a function, given an input like x equals -1, that input leads to a point. That point leads to a y value. When I trace an x value to a point, that kind of makes a vertical line, and we have what's called the vertical line test. What the vertical line test means is any vertical line you draw through a graph, if it hits no more than once, that means you have a function. If it hits more than once, you don't have the graph of a function. So that's a function. If I tried to draw a picture that looked like that, it would not be a function because it often fails the vertical line test. All right, so most of the things you've graphed are functions. A few things aren't. In 95, you might have graphed a parabola. Looks something like that. Parabolas pass the vertical line test, at least that kind. However, you may have graphed a horizontal parabola. Oh, my pink's dying. Can you even see that? Let's see. Faintly. I need a new pink. Fine, we'll use pencil. And that fails the vertical line test everywhere except the vertex. So this is not a function, not a function, yes, a function. Little smiley facey. Okay, so that's some general ideas about functions. Other ideas about functions. Idea of domain. Domain relates to what can you input. What can you input? Well, looking at this guy, x is my input variable. It's a placeholder waiting for me to give it a number. And what do I do with it? Well, once I give it a number, order of operations says I have to multiply by 5 and then add 2. Well, I can multiply 5 by any number. 0, -1, 5 halves, 3/16, pi. So that's kind of cool. And I can add 2 to anything I want. So in most cases, the domain is going to be all real numbers. We'll get to some exceptions in a minute. Okay. All real numbers can be illustrated in interval notation. As being the whole number line, which means to the left forever. That's what that means. And on this side, to the right forever. That's what that guy means, at least in this case. That's how they spell it in Rhode Island, by the way. Let's see, what else? Domain. Domain, you can usually look at the equation and guess at the domain with a little education. Range, you kind of have to look at the graph. Looking at the graph here, my line seems to rise forever and drop forever. Range is related to my output, my y values. Oops, that's almost off my screen. There we go. What do we get out? And that's my y. In this case, so again, these are x's, these are y's. Since it goes up forever and down forever, it seems to be the same idea for the range. And that is from -infinity to infinity, which is what the computer forces you to type. All real numbers is a great answer also if it's on paper. Pretty cool, huh? All right, let's look at another function. So I expect you to be pretty familiar with linear functions, domain, range. Another kind of function I expect you to be familiar with are quadratic functions. Chapter 2 is all about quadratic, but you've seen them a little bit before, and chapter 1 focuses on them a bit. The most simple quadratic function is y equals x squared. We can square any number we want, so I believe the domain is all real numbers. We'll look at the range in a minute. Since I believe it is a function, which means given a particular x value, that leads to no more than 1y, it's a function. Y is a function of x. That's way too much writing for a math person. Y is a function of x. Shorthand, which is great for substitutions. F of x equals x squared means f of blank equals blank squared. So if somebody says, please square -2, and I go over here and put a -2 in there, I know that means take -2 times -2. Wrapping things safely in parentheses gives me +4. Try typing that on the calculator. Gives you the wrong answer. It's a bad order of operations problem. Even Google has a problem with that. Google knows everything. Oh, by the way, graphing calculator is a helpful thing. Here's my handy dandy TI. Sorry, a little bit of glare there. If you have one of these, they're lovely tools. So I can just type, so by the way, y equals brings you this menu. I call this the function screen. And in the function screen, I want to take x and I want to square it. The next thing you have to do is tell the calculator where to look at the graph. That's what window is all about. Typical starting window is -10 to 10 for x. Scale, put a mark every 1 unit. Y, -10 to 10. This is called a standard viewing screen. Scale by 1. Don't worry about the resolution. And then we hit graph, and we see that beautiful parabola in a nice shape. If you have dish TV at home, then you are very reliant upon this shape. That window right there, quick button to get it, is Zoom 6, Zoom Standard, automatically graphs from -10 to 10. Here I can look at the graph and see that there's nothing going on below the x-axis, so no negative y's are needed. So I could go tweak the window. Oh, sorry about the glare. And, oops, I want to make the minimum 0, so I can always manually enter a window. Notice with 10 high, I get this white space on the side. I can hit trace and see that when x is about 3, y is over 10. 3 squared is 9, right? So I could adjust the window again. If I'm only going to go 10 high there, then I could go over here and say, just show me x between -3 and 3. Then the parabola fits the window quite nicely. Alright, zoom out again. Could either zoom out with the zoom out option, number 3, or do a zoom standard, which I'm going to do. Okay, the reason I want to do zoom standard is just to point out, notice there are no negative y values. The lowest y value is y equals 0, which happens when x equals 0. So all the domain here is all real numbers. The range, looking at the graph, are only y values that are greater than or equal to 0, which means on a number line we would shade 0 and say anything greater than 0 is good. And if I use interval notation, that means square bracket 0, comma, go to the right forever, parenthesis, which is the way the computer likes it. Okay. Alright, let's see. Some other cute things about graphs. Let's look at a more interesting one. You can shift a graph right 2 units by replacing x with something like x minus 2 in parentheses. So if I were to graph y equals parentheses x minus 2 squared outside, I should see the same exact shape, just shifted over. Oh, my battery's dying, and I have 2 minutes left before YouTube rejects this video. Alright, so let's just do a couple more things, and we'll come back to this in a little bit. Parentheses, x minus 2, close it, square it, graph it. Look at that, 2 units over. Pretty cool, huh? Sweet. Alright, another thing I could do to this thing is I could drop it down. Let's drop it down 1 unit. So to drop down 1, you would just subtract 1 from the function. So my function was x minus 2 squared, now I want that minus 1. So now I should see the same graph as this, just drop down 1. So let's take a look at that beauty. So to the outside here, I'm going to subtract 1, graph. Ooh, look at that. It's like the regular parabola. The vertex from the origin moved 2 right and 1 down. So I believe the vertex here is 2, -1. So you should know all about vertices. I believe it is 2, -1. Well, think way back to Math 95, quadratic formula. Part of that said if you had something that looks like ax squared plus bx plus c, the x value for the vertex is going to be negative b over 2a. Well, that means I have to multiply that out. X minus 2 times x minus 2, then subtract 1. Well, multiplying that out gives me x squared minus 2x plus 4. Minus 1 is still chilling out there. Cleaning up like terms, I get x squared minus 4x plus 4 minus 1 is plus 3. The negative b over 2a gives me the opposite of negative 4. That's b over 2 times 1, because that's 1x squared, which gives me 4 over 2, which is 2.